Yeah.
Your interconnect.
Good afternoon and welcome back to this afternoon session of National Mathematics Day celebrations. The essence of mathematics is to make complicated things simple and not to make simple things complicated. In order to understand the universe, you must know the language in which it is written, and that language is mathematics. With this interesting note, I shall now invite Professor Dr. S. Ramakrishnan, Head of the Department of Science and Humanities, Sri Sairam Engineering College, to introduce the chief guest, Dr. Srinivasa Rao, for this wonderful occasion of 133rd birth anniversary celebrations of Srinivasa Ramanujan.
Madam, is my voice audible?
Yes, sir. Yes, sir.
Okay. Good afternoon to one and all who have joined this webinar session online. On this auspicious day for mathematics fraternities, on behalf of the Department of Mathematics and the Mathematics Club of Sri Sairam Engineering College and Sri Sairam Institute of Technology, I take great pleasure in welcoming all of you for the second round of webinar of the day. On this memorable day, I feel glad to introduce and welcome our chief guest, Dr. K Srinivas Rao, former Senior Professor of Institute of Mathematical Sciences, Distinguished DST Ramanujan Professor, Srinivasa Ramanujan Center, Kumbakonam, Honorary Director, Srinivasa Ramanujan Academy of Mathematics, Chennai. We are indeed blessed to have Dr. Srinivasa Rao as our resource person for this webinar session on life and works of Srinivasa Ramanujan. Dr. K Srinivasa Rao was born in Madras, now Chennai. He is a first-class student in BSc Physics from Vivekananda College, Madras in 1961 and possessed a higher first class in his post-graduation in Physics from Presidency College in 1964 and secured 4th rank in the University of Madras. He has to his credits a Proficiency Prize awarded by Presidency College, Sita Lakshmi Subramanian Prize, Dr. Kalyanaraman Memorial Prize for Physics in 1963 and 1964, and Jones Memorial Senior Prize in 1964 and 1965. His doctoral degree on theoretical physics is from the Institute of Mathematical Sciences, Chennai, under the supervision of Professor Dr. Alladi Ramakrishnan, Founder Director, Math Science, Madras. Dr. Rao started his career as a demonstrator in the Department of Physics, Vivekananda College. His career journey includes being a research trainee, CSIR Junior and Senior Research Fellow, Assistant Professor, Associate Professor, Professor, and Senior Professor in Institute of Mathematical Sciences, Chennai. His research topics include quantum theory of angular momentum, special functions and orthogonal polynomials, and computational methods. He has been a visiting associate professor, fellow, exchange scientist, visiting scientist, visiting professor, senior scientist, and resource person to prestigious international universities in US, UK, Germany, Italy, Belgium, etc. He has been elected fellow, National Academy and Tamil Nadu Academy of Sciences. He is editor of the newsletter of the Society for Special Functions and their Applications. He is a life member of Ramanujan Mathematical Society, life member Special Functions and their Applications Society. He is a recipient of TANSA Award for Popularization of Science and TANSA Award for Mathematical Sciences. He has convened and conducted many symposiums in wide range of topics in physics, mathematics, and computer science. Dr. Rao has authored, edited, and reviewed many books. Few of the books authored by him include Introduction to Computers and Programming, Quantum Theory of Angular Momentum, Selected Topics, Srinivasa Ramanujan, a Mathematical Genius. He has edited and reviewed many books on theoretical nuclear physics, theoretical physics, nuclear physics, and mathematical physics. There are many Indian editions in which he has authored, co-authored, and written prefaces and forewords. He has been reviewer for Journal of Mathematics and General Physics, Pure and Applied Physics, IIT Journal for Mathematics and Physical Sciences. He has published several research articles in various international and national journals and national and international conferences. She has addressed on several topics and interviewed several leading scientists and mathematicians in various media. We are indeed happy to have him amidst us as our chief guest on this National Mathematics Day. I once again welcome all the participants who have joined us online.
Thank you, sir, for the introduction. I now hand over the session to our chief guest.
I thank Professor Ramakrishnan, Dr. Subhatra, and the members of the Sairam Engineering College for inviting me for this webinar on the life and work of the mathematical genius Srinivasa Ramanujan. I have been interested in Ramanujan ever since the centenary of Ramanujan, which happened on December the 22nd, 1987. So without giving any more details about this, let me go into the presentation which I have prepared for you. Actually, this was intended for people who are beginners. I mean, people who are not fully aware of the life and work of Ramanujan. And it is not intended to be a mathematical lecture, because if that were the case, then I would have started in an entirely different way. So we are now going to talk about the life and work of Ramanujan. So let me go into the slides. Ramanujan has been compared to all-time greats Leonhard Euler, Carl Friedrich Gauss, and Jacob Jacobi. For what? For his natural genius. Mark Cutts, a contemporary mathematical physicist, has made the following statement: the working of their minds is for all intents and purposes incomprehensible. Even after we understand what they have done, it is completely dark. This is equally true of Ramanujan, because even though we know that he has obtained 4,000 results, which are called as theorems of great importance in mathematics, we do not know how he was able to arrive at them. How he could just look at the tip of the iceberg and draw the picture of exactly, or rather the photograph of the iceberg. So it is like a hologram. You know, he had the ability to look at one equation, one entry, which was called the Gauss summation theorem, and from there derived what is known today as the most general summation theorem in generalized hypergeometric functions. That is what fascinated me, and why I went from hypergeometric functions, which was my area of research at that time in special functions, into the study of the life and work of Ramanujan, which I took up seriously after 2002, after my superannuation, and that has paid me rich dividends. If today I am addressing all of you and having the pleasure of talking to you about the life and work of Ramanujan, it is because of the dedicated work which I was able to put in for about 5 years continuously on the life and work of Ramanujan. And you will see what the results are, because I got all the work of Ramanujan scanned long before the notebooks became brittle and you cannot even open them today. But all the results which are there in the notebooks can be seen by anybody, anywhere in the world, at any time, because they were scanned when they were in good shape already around 2002 to 2003, 2004, around that time. For nearly 2.5 years, I devoted all my time and energy to study the notebooks of Ramanujan and the work of Ramanujan, prepare two CD-ROMs on the life and work of Ramanujan, along with a website, which I will leave with you for you to enjoy as and when you like what you want to see about Ramanujan. Bruce Berndt has spent nearly 2.5 decades, nearly 27 years, and even now continuing to work on Ramanujan. He spent nearly 22 years between 1974 to almost 1997, when he brought out a 5-part work on entitled Ramanujans Notebooks, Part 1, Part 2, Part 3, Part 4, and Part 5, which contained the proofs, at least one proof for each one of the entries of Ramanujan which were made. Now let us look into the life of Ramanujan. What you see here is the Gopuram, or the Sarangapani Sanidhi Street temple, Temple Street. It's the Sanidhi Street in which the Sarangapani temple is. And the picture, if you look at the right of this, just outside the purview of the picture, which you are cut off from the house of Ramanujan, which I will show you in another slide. So Ramanujan was living in this particular street until he came to Madras for better prospects and for higher studies. He went to Pachepas College, and when he came to Madras, and then he never went back to Kumbakonam for studies. The picture which you see on the right is that of Komalathammal, the mother of Ramanujan. The father, Srinivasa Iyengar, was a gumasta, or an assistant to a cloth merchant in Kumbakonam. The mother's parental home was Erode. Therefore, Ramanujan was born in Erode, and he was the first of 3 sons. He was born on 22nd of December, which was a Thursday. The name Ramanujan is automatically chosen by Iyengars if a boy is born on a Thursday. And Ramanujacharya was the founder of Visishta Advaita philosophy. There is Advaita, there is an Advaita, and this one is called a Visishta Advaita philosophy. Ramanujan studied in a primary school called Congayan Primary School, which no longer exists. He stood first in Kumbakonam. He stood first in the Tanjore district primary examinations of that Congayan Primary School, and because of his performance, sorry, it's running to prevent it from running. So he stood first in the Tanjore district primary examinations held in November of 1897, and this entitled him to a half-year concession in the town high school at Kumbakonam, where he studied from 1893 to 1897. He passed the matriculation examination of the University of Madras. In those days, matriculation examination was conducted by the university. So he passed the matriculation examination of the University of Madras in 1904. And above, what you see is a photograph which I took when I visited in 2002. And luckily, the school had got a new coat of paint at that time. And that's why the picture is so beautiful. These are a few of the anecdotes which I can pass it on to you as very authentic anecdotes. One, he was entrusted with the task of preparing the conflict-free timetables for the whole of the school by a senior mathematics teacher whose name was Ganapati Subba Iyer. So Ganapati Subba Iyer found that this Ramanujan was very precocious, and so he asked him to prepare the conflict-free timetables for a school which had about 1,400 students at that time, and from first form to sixth form, which were the forms at that time. So it was not an easy task, and it was entrusted with the mathematics teacher who trusted Ramanujan to do this. And what is the consequence for mathematics? Ramanujan then decided that it would be interesting to fill those squares with numbers. So his first chapter in his first notebook is the only one which has a title which is entitled Magic Squares. So I will come to that a little later. I only told you that his research in mathematics are rather what I would call as recreational mathematics. Writing down a magic square, date magic square is recreational mathematics. It is not higher level mathematics. So it is not research level mathematics. It is recreational mathematics. So Ramanujan did this recreational mathematics. Even when he was asked to do the timetable for the school, he started doing the recreational mathematics of magic squares. And I will show you what he did a little later. In a division class, the teacher was apparently trying to generalize without being very careful. So he should have said, so if there are 3 of you and I give the 3 bananas to 3 of you, each one of you will get a banana. Ramanujan is supposed to have put up his hand and ask, sir, if no banana is given to no student, will each student still get a banana? This is a joke, actually. It looks to me to be a joke. But at that time, all the children could also understand this, and they laughed. What Ramanujan was trying to point out was that the teacher was not careful. He should have written n by n is equal to 1 for all n equal to 1, 2, 3, etc. or all integer other than 0. For all n not equal to 0, he should have written. So obviously the teacher did not write that. And so Ramanujan had the cheek to ask the question, sir, if no banana is given to no student, will each student still get a banana? Another of the anecdotes which has been left behind for us is the following one, that apparently he was in a middle class. I mean, middle in the sense he was in the 4th form, and there was a student, he was in the 5th form, and there was a student who was below him in the 4th form, and there was one student who was above him in the 6th form. So the 5th form boy had 2 friends, one a student in the 6th form, and one other Ramanujan in the fourth form. So the sixth form boy said that seems that you always say, this sixth form boy was telling the fifth form boy that you always say that you have a friend who is a genius. Let me see if he is a genius, whether he can solve this question. What was the question? If root x plus y is equal to 7 and x plus root y is equal to 11, what are the values of x and y? And this friend in the sixth form said he was learning at that time simultaneous equations in two variables with square roots. So he knew how to solve that. You have to write down half a dozen steps to get the answer. So he thought if there is this boy Ramanujan is called a genius, he must be able to get the answer somehow without having to work it out. So it so happened that this boy in the fifth form, when he asked Ramanujan, Ramanujan immediately gave a quick reply without even using pen and paper. He did it as a mental sum and he came out with the answer x is equal to 9 and y is equal to 4. And this one for him, a devoted friend. And the name of this boy who was in the middle was C.V. Rajagopalachari. This was the house in which Ramanujan had lived when he was in Kumbakonam. Okay. An early photograph of Ramanujan's parental home in Kumbakonam, which is in Sarangapani Street, which was acquired in March of 2002. The Vice Chancellor, Professor Sairam, was responsible for acquiring it for the so he was acquiring it for the college, for the university, and it was dedicated to the nation by Professor Dr. APJ Abdul Kalam and dedicated as a museum, national museum. So today it looks very different. It is not like this. It has been, this is the oldest photograph, but when they acquired, it was already in a different shape. It had a basement, not a basement, it has a staircase to take you to the first floor and things like that. So that photograph, if it is there, it will come a little later. So anyway, Ramanujan was considered precocious at school, especially in mathematics, and he won several prizes for proficiency in his second, fourth, and sixth years at school. These are known as second form, fourth form, and sixth form, which are equivalent to something like about the seventh standard, the ninth standard, and the 11th standard. And one of the books which he got as a present was, fortunately, Loney's Trigonometry Part 2, which he mastered when he was in his fourth year at school, which was in the fourth form of his school. Ramanujan won several special prizes for proficiency in mathematics, as I mentioned to you. He was also proficient in English language. So he was awarded in 1904 at a public function a special prize. And that is the first public recognition which he received for proficiency in mathematics. He passed a competitive examination in English and maths and secured, therefore, a scholarship to join the Government Arts College in Kumbakonam in the first degree in arts, or what was known as the FA class. This is the first proof of the fact that he entered the Madras University, and this is a certificate which says that it certifies that he attended the junior first arts class of the Kumbakonam College, which is the Government Arts College of Kumbakonam. Ramanujan was not promoted to the senior FA class in 1905 and therefore lost his scholarship. Only students who pass will continue to get the scholarship. So since he failed, why did he fail? I'll answer that. He appeared for the Madras University examination again in 1907, but unfortunately he again failed. This marked the end of his formal education in India. And why did he fail? He failed mainly because he had an aversion, being an Orthodox Hindu, Brahmin, Iyengar at that. He had a dislike for non-vegetarian and anything which had to do with cutting of animals and so on. Apparently in a biology class, the teacher brought to the class a bullfrog, which means a big frog like this. And he had to cut it to show the innards of the bullfrog, to say how the digestion system of the bullfrog works. And apparently Ramanujan was not able to stand this. He was almost about to vomit. And he then did not attend the classes any further. So when he had to write the examination, he apparently cheekily wrote on the answer script, "Sir, this is the undigested portion of the digestion class," and returned it to the teacher. And therefore he was not promoted in biology. So if you fail in one subject, you are a failure still. So he did not do well in biology and other subjects, and therefore he was detained. So he never passed the FA, first degree in arts, which is what you call as equivalent of 11th standard today or intermediate first year in those days. Now, the book which inspired him was the following. So between the years 1905 and 1909 or 1909, he published his first paper. So in those 4 years, it is not very clear as to what he did to survive. So he apparently was taking tuitions to augment the income of the family. And he also once ran away from home in search of jobs, they say, to Vizag. So in fact, only in recent times, hardly about a few years ago, I was able to get a newspaper clipping from the Hindu, which says missing boy. And that missing boy was none other than Ramanujan. And fortunately, he came back after about a week of absence from Kumbakonam, saying that he had gone to Vizag in search of jobs. The house in which Ramanujan was living, which in Kumbakonam, there were 2 students who were coming regularly as boarders. The reason why they were coming for boarders was mainly because Komalattamal, the mother, she thought that she would augment the income of the home by providing food for the boarders. And the boarders were boys who were studying in college. So naturally, they would have come a little earlier than what was required, and then they would have to wait until the meal was being cooked. And during that time, they would be sitting in the payal in front of the house, and they were discussing some mathematics. And they were struggling with the problems which were being given to them at the collegiate level. Ramanujan was a schoolboy, and he would just go and listen to that, and then he would tell them, no, this is not the way in which this problem should be solved. This is the way in which this problem should be solved. And he would show it some shortcut methods of doing it, which they were amazed to find were simpler, much simpler methods. When they went back to the school and told the teacher that, sir, this is a shorter way of doing it, actually the teacher knew the intelligence of those boys. So he said, tell me who taught you this? And they said, sir, it is a schoolboy. And who is that schoolboy? Srinivas Ramanujan. So that is how Ramanujan came into contact with these college boys, who fortunately brought for him this book which you see here, which is called K Synopsis. It's entitled A Synopsis of Elementary Results in Pure Mathematics, and it's an abridged demonstrations. There are only abridged demonstrations in this. It was brought, it has contained only propositions, formulae, and methods of analysis. It does not give proofs. And so something like about 4,000 theorems were there. And those theorems were the ones which inspired him. So K's book covers roughly the subjects of Schedule A of what is called today as the Mathematical Tripos Examination of the Cambridge University. And it is effectively a synopsis it professes to be, because it contains the enunciations of mathematical theorems systematically and scientifically arranged with proofs, which often were not more than cross references and a few lines here and there, but not explicit. And these are the least interesting parts of the book. All this is exaggerated as, sorry. So all this is exaggerated in Ramanujan's famous notebooks, which contain no proofs at all. There are very few cases where there is a small hint which is given of a proof, but no proofs are given in this. And this is the style which was there in K Synopsis. K Synopsis was a compilation of results. For those of you who are research workers, you would go and look for books like those of Gradstein and Reisig, if you want to know whether the formula which you are having is a correct formula or not. So this K Synopsis, as it is called, in short, it is called as a K Synopsis, has been the book which inspired Ramanujan to write down the results of in his notebooks. There are 2 instances in his life where he come across this figure 4,000. One, that there were Nalaira Divya Prabandham. For those who know Tamil very well, Nalaira Divya Prabandham are 4,000 compositions by about 13 Alvars who wrote down varying lengths of poems in praise of Lord Mahavishnu. So that was one place where he saw 4,000. And his mother could recite, as I told you, 1,000 of those 4,000 pasurams, as they are called. And Nalayara Divya Prabandham pasurams. And that gave him the memory power to recall whatever he had acquired in his life, whatever he had discovered, he could always recall without any problem whatsoever. So that is one place where he came across the number 4,000. The second was this K synopsis. Therefore, he should have thought there were 4,865 theorems by one reckoning. In fact, there is a small anecdote about this. The last entry is 6,300 and odd or something like 6,000 plus. Let me put it at 6,000 plus. So Hardy, in his book, in his articles, after Ramanujan died, about Ramanujan, said that Ramanujan had mastered all these 6,000 theorems. But it was given to Professor Richard Ascii. For those of you who are specialists in polynomials, orthogonal polynomials and things like this, you should know that there is a scheme which is known as the Ascii-Wilson polynomial scheme, which starts with a hypergeometric function called a 4f3 and comes down to the exponential function, which is the lowest function. So that scheme is due to a person called Richard Ascii. So this gentleman, Richard Ascii, who is unfortunately no more with us. In fact, it's fortunate to have just exactly where I am seated next to me. I was at that time, of course, this comfortable chair was not there. I had another chair, and Ascii was sitting next to me here, and I was explaining to him some things which I was doing in the area of special functions, and he was a visitor to the Institute of Mathematical Sciences at that time. And Ascii comes up later on in the story also, because it was he who went to my wife at that time when she was visiting in the United States and sold her the first card which contained the bust of Ramanujan, the statue of Ramanujan to be made. And when he saw that my wife was wearing a sari, he said, "You must be an Indian. Where are you from?" And the moment she said she's from Ramanujan Institute, then he said, no, then I cannot sell it to you because you are from Ramanujan Institute itself. But still, I think she paid $10 and got that copy of a statue or a bust of Ramanujan to be made. I will show you the bust of Ramanujan a little later. So that bust of Ramanujan, there are 10 copies of that all over the world, and I will tell you also more about it at that time when we come to that. So at this present moment, let us now continue and then say that Ramanujan's ideal was the presentation in K synopsis. So as this, he continued to make his presentation. It is Hardy who says that one can see Ramanujan's ideal of presentation has been copied from K synopsis. Now, how many notebooks are there? There are 3 notebooks of Ramanujan. Okay, I should not press on that. That's the mistake which I'm making. If I press on that, it goes to the next one. Okay. There are, the number of notebooks is 3. The first notebook contains 16 chapters and is 134 pages long. The second notebook is 21 chapters and 252 pages long. For example, in the first chapter, which is the only one in first notebook, that's the only one which has the title Magic Squares, and it is only 3 pages long. The first chapter in the second notebook is also on Magic Squares, no title though. No chapter has any title except that first chapter in the first notebook, and that runs to 8 pages. So obviously Ramanujan was trying to copy his results in the first notebook, and he was not a copyist. He was not working for anybody. He was working on mathematics. Therefore, when he copied, he added many more results, and that is how it ran to 8 pages. And the first chapter of the second notebook ends with an 8x8 magic square, in which there are 4 4x4 magic squares also. So that tells you his ability, and that is why people say that the second notebook is considered as a revised, enlarged version of the first notebook. And believe me, when I mentioned this to you at great length, it doesn't mean that this was great mathematics. If you are able to do magic squares, it doesn't mean that you are a mathematician of the caliber of Ramanujan, because this is trivial mathematics. I would consider this as recreational mathematics. The third notebook contained unorganized material, and it is only about 33 pages long. And possibly this was written during the last years of his life. One doesn't know exactly when he wrote any of these entries, when he made any of these entries, but it is obvious that he had these notebooks somewhere between 1905 and when he left the school, left the college, and 1909 when he wrote his first paper, because he was taking these notebooks and going in search of a benefactor and showing it to various people what were the contents of these notebooks, and they were all amazed to find the depth and the quality of the results which were contained there. And several of the mathematics professors, the MAs in mathematics, who looked at those results, were baffled because they knew nothing about them, and they were not very sure. They were skeptical whether they were right or wrong. But they knew that he was a genius, because if he was asked to give a proof, he will give more than one proof for any one of the entries which were there in his notebooks. So that is how he had a group of people in India who were responsible for telling him how to go about and make a name for himself. So Hardy says, any student who looks at the notebooks can see that Ramanujan's ideal of presentation had been copied from Carr's synopsis. I mentioned to you about Carr's synopsis. I showed you a few pages also there. Hardy spent about 3 to 4 months after Ramanujan died, around 1923 or so. Ramanujan died in 1920. Around 1923-24, Hardy spent about 3 to 4 months editing one chapter on hypergeometric series, and realized that it would be a formidable task if he were to do something like that. Because if he wanted to edit the notebooks of Ramanujan, his whole lifetime would be spent on that, and he would not be able to do any of his own original research work. He would only be thinking, how did he get this result? Is that right or not? How can I provide a proof? And so on. So that was not what he wanted to do. So he abandoned this job of editing of the notebooks, and he, with the following statement, that a systematic verification of the results in his notebooks would be a very heavy undertaking, and he was not willing to do that heavy undertaking. So then Hardy persuaded the University of Madras in the year 1931, that is 11 years after Ramanujan died. Hardy persuaded the University of Madras and sent the notebooks back through S.R. Ranganathan, the first library scientist of the Madras University, telling him that the S.R. Ranganathan did his PhD in library science in Cambridge and in Trinity College. That is how Hardy came to know him. So when he came to know that there was a person, another Indian who was doing, and he was a South Indian at that, he obviously gave the notebooks to him and said, and he was also a library scientist. He was a librarian. He was doing PhD in library. So he was to become the librarian, chief librarian of the Madras University for a number of years. So he told S.R. Ranganathan, Ramanujan is your countryman, so these notebooks should belong to you. And he gave the original notebooks back to Ramanujan. How did they reach that place? That is another question. That's a small story, but let me not go into that branch, because that will again take a few more minutes, and I will not be able to complete my lecture in the time which is allotted to me. So Hardy then persuaded the Madras University in the year 1931, and Hardy entrusted this work to G.N. Watson. For those of you who are familiar with higher level mathematics, Watson's work on Bessel functions is a treatise. It is a book which is about 600 pages long, or at least more than 600. It is this big. As you can see, it will be a few inches thick. And Bessel functions by G.N. Watson is still considered as the classic work on Bessel functions by anybody. So Watson undertook this responsibility of editing the notebooks of Ramanujan along with a junior person by name B.M. Wilson. As ill luck would have it, the two of them were working on it together, but by about 1935, 4 years after they started looking into the notebooks of Ramanujan, and they had not completed any of the work still, and there was a lot of work which had still to be done. Wilson died, and somehow Watson's interest waned, and the work was abandoned. So the editing of the notebooks was not done after that. The Indian Mathematical Society was founded in the year 1909. So I mentioned to you about the notebooks because it was between 1905 and around 1909. 1909 was the year when Ramanujan wrote his first paper, which was published in the Journal of the Indian Mathematical Society, a very long paper about which I will tell you a little later. It was on Bernoulli numbers. I will come to that a little later. So 1909, in those 4 years, Ramanujan used to derive a lot of results. He would go and show them to a couple of mathematicians whom he knew. I will be mentioning the name of Narayana Iyer. He was an MA in mathematics. And Seshu Iyer was an MA in mathematics. So he would show these people those results, and they were all baffled. And he would ask them, where do I publish this? Can I get them published? Can I get them published? So they would say that we do not know where to publish it. And then they were always at a loss to tell him exact place where they could get published. And therefore, it was at that time this gentleman called Ramaswamy Iyer, who was also a mathematician, who was an MA in mathematics. He decided to found the Indian Mathematical Society. So Indian Mathematical Society was founded in the year 1909 by V. Ramaswamy Iyer, who was not a professor anywhere, but because he submitted a paper to London Journal and that accepted the paper, and in the card which they sent, they wrote Professor Ramaswamy Iyer. So all his friends started calling him as Professor Ramaswamy Iyer. So let us also continue to call him as Professor Ramaswamy Iyer, because after all, he has done a great service to mathematicians in India by founding the Indian Mathematical Society and also starting the Journal of the Indian Mathematical Society. There was one section in the Journal of the Indian Mathematical Society which was known as the questions or answers to questions section of the journal. So it is here that Ramanujan published several questions or answers, I think 59 by one count. I will tell you about that by the end. So he had something like about 59 questions which were there. And one of those questions is something which is intriguing, because it was a school teacher by name K Srinivas who had brought this to my notice a long time ago when he published small notebooks, small booklets. One of them was called Mathematics for School Students at the primary level, at the middle school level, and the secondary school level. So in those three small booklets, he took out some of the very simple results of Ramanujan. Something like about 5% of those 4,000 theorems which Ramanujan discovered will belong to a category which could be called as school mathematics. I mean, at the level of school mathematics. But then, not the school mathematics for ordinary students like you and me, but for a bright student like Ramanujan, it was school mathematics. And you can see how bright this simple problem was. He was asking several people, what is the value of a nest of roots? Square root of 1 plus 2 times square root of 1 plus 3 times square root of 1 plus 4 times square root of 1 plus dot, dot, dot. So it goes on and on and on, right? It will never end because n goes from 1 to infinity. So it goes on and on and on. And the next one starts slightly differently. It starts instead of 1 with 6. And 6 plus 2 times square root of 7 plus 3 times square root of 8 plus 4 times square root of 9 plus 5 times and so on. And then he wrote dot, dot, dot. Actually, he wrote and C because that was the notation which he used. And I have put here the modern notation to put dot, dot, dot. And so this baffled all the students, all the people who he asked. They were not asking him, what is the answer? What is the answer? And he would say with glee that the first number is 3 and the second number is 4. And they were surprised. And they asked him to publish, they asked him to prove. And then he gave proof. So this is at the 5% of his proofs, 5% of his theorem, elementary level, which you and I, everybody can understand, but never thought of. Solution for the first one is f of n, let function of n be n into n plus 2. Then you take baby steps. N plus 2 is square root of n plus 2 whole squared. N plus 2 whole squared is n squared plus 4n plus 4. Take out 1 and you will find you will get 1 plus n squared plus 4n plus 3, and realize that n squared plus 4n plus 3 can be written as n plus 1 into n plus 3. And now realize that n plus 1 into n plus 3 is nothing but f of n plus 1. So f of n is the fourth line tells you that f of n is equal to n times square root of 1 plus f of n plus 1. That is what you call as a recurrence relation. So you can now write f of n plus 1. Substitute f of, instead of in fn, if you put f of n plus 1 there, you will get n plus 1 times square root of 1 plus f of n plus 2 for f of n plus 1. Now this you can continue ad nauseum. You don't have to stop. And now you put n is equal to 1 on the right hand side, you will get the nest of roots in question 289(1), which is square root of 1 plus 2 times square root of 1 plus 3 times, etc. So that nest of roots comes. Now put n is equal to 1 into n into n plus 2, you will get it as 3. So very trivial, very simple. Now, if you look at the next one, which is question 289 part 2, it starts with n into n plus 3. N plus 3 is written as n plus 3 whole squared. Here he slightly is different. He does something slightly different. He takes n plus 5 has to be taken out if you want to write f of n plus 1. So the fourth line here is f of n is equal to n times square root of n plus 5 plus f of n plus 1. Now continue the recurrence and you will get a nest of roots on the right hand side. If you put n equal to 1 on the right hand side, you will get the nested root on the right hand side. If you put n equal to 1 on the left hand side, you will get 4. So now this looks to you and to me to be really a beautiful result. Now, how would Ramanujan have discovered this, and what would he do if he had results like this? Now, normally, you and I, if we say that I have a formula for 3, I have a formula for 4, get me a general formula, we will look for a formula for f of, what will you look for? F of n plus 2, if you define n as 1, 2, 3 to infinity, you will look for a formula for f of n plus 2. Or you will look for a formula for f of n itself. Now, you will see what Ramanujan did. And how did he arrive at this? Now let me show you what he did. Ramanujan, however, noted the nested root formula for any number in his notebooks in a slightly different way. Ramanujan writes the result for any given number partitioned into 3 parts. Now, that is something not you and I will not do. Sorry, I had a cup of water. Okay. Unlike the conventionally trained mathematics students who are being self-taught, he considered x, n, and a all as integers. This is obvious from what he has written down. But what would your mathematics teacher and my mathematics teacher will say? X is a variable, n is an integer, a is a real constant. For him, because he was not formally trained, x, n, and a are all of the same footing. So he wrote down general entry in his notebooks as x plus n plus a is equal to n times square root of ax plus n plus a whole squared plus x times square root of, and so on. In that, he said, if you put x is equal to 2, n equal to 1, a equal to 0, you will get the first result, question 286, 2.1. And the second answer, second will come when you put x is equal to 2, n equal to 1, and a equal to 1. So you can see the ingenuity of a creative mind for even a simple problem like this. Now, you can go one step further to understand how Ramanujan would have arrived at this. Now we will see, why did I not think of it? Why did you not think of it? Why did not everybody else think of it? Why only Ramanujan? Now read for yourself. 3, every one of us knows is square root of 9. Now 9 you can always write as 1 into 8. 8 you can always write as 2 into 4. 4 is now square root of 16. 16 is 1 plus 15. Now we go on doing that. You will get the nested root, which is in the last line here. Start with 4, but now you have to take 6 plus 10 to be able to get the nest of roots again. That was the beauty. So here you can see in elementary mathematics, I do not know how many of you have already known this. If so, I'm just carrying calls to Newcastle or carrying calls to you, carrying Ramanujan's result to you. But for those who do not know, it's something which you can always admire in Ramanujan. Now, these are the people whom I would call as the benefactors of Ramanujan. Now, Seshu Iyer was his teacher in Government Arts College in Kumbakonam, and later he got transferred to Madras, and he was in the Presidency College, and he retired from the Presidency College as the head of the Department of Mathematics. Narayana Iyer was at that time a treasurer in the Madras Port Trust, and it was luck that Narayana Iyer was living in the same area in which Ramanujan was living. They were both living in Triplicane, and therefore Ramanujan chanced to come across Narayana Iyer and started telling him that he knows mathematics. When he knew that he was an MA in mathematics, he started telling him about his mathematics. Also, I told you that when he met Ramchandra Rao directed him to meet Ramaswamy Iyer. And Ramaswamy Iyer, the founder of the Indian Mathematical Society, knew Narayana Iyer. So that is how the chain came. And that is how Ramanujan was put in contact with Narayana Iyer. So Ramanujan, when he found these people as benefactors, right? He was taking his notebooks and he was asking them to give them some money to support him or find him a job to continue his livelihood, and so that he can continue to do his mathematics without worrying about where he would be able to buy his next meal. Ramaswamy Iyer founded the IMS in 1909 at Salem. Diwan Bahadur Ramchandra Rao was collector of Nellore in 1910. Seshu Iyer and Narayana Iyer were, Narayana Iyer was the manager of the Madras Port Trust, Seshu Iyer was the professor in Presidency College, and they all made him approach Sir Francis Spring, who was at that time the chairman of the Madras Port Trust. And Sir Francis Spring he needed no further introduction because Narayana Iyer was working for him, and he knew Narayana Iyer was a very good human being and a very good mathematician. and he was the treasurer. So when Narayana took Ramanujan, and actually he did not take him directly like that. There is a small snippet of information here. One day, apparently, Ramanujan had taken some files to his home and brought back those files and returned them without realizing that he had left certain loose sheets of paper in the file. So the file went to Diwan Bahadur, Ramchandra Rao, the collector of, Sir Francis Spring. And Sir Francis Spring suddenly found that these papers had nothing to do with anything to do with Madras Port Trust. And they were all scribblings and they were all writings about mathematics. So he called Narayana and asked, what is all this? And he himself being a erudite scholar, probably knew that amount of mathematics to understand that it was good mathematics which was being written there. Then Narayana told him about Ramanujan, and then he said, it seems, why don't you bring him here? And that is how he was given a class 3, grade 4 clerical post in the Madras Port Trust with no responsibilities. That was the help which he got from Sir Francis Spring. And not only that, the recommendation was made by Sir Francis Spring to Lord Pentland, who was the governor of Madras at that particular time, about Ramanujan being very precocious. And can you believe this? A person who is a dropout in the 11th standard of today's standards, or in those days FA class, was awarded the first ever research scholarship at the University of Madras for mathematics. And it is the first ever for any subject. So it is the first ever scholarship that was given to mathematics, and that was given to Ramanujan, and it was a princely sum. You should remember the year is 1909 or 1910. So at that time, 75 rupees a month was a princely sum. His father was earning only a salary of 25 rupees a month as a gumasta to a cloth merchant. So you can see how he got recognition. So there are many people who say that Hardy is the person who recognized Ramanujan. But I would say that it is Ramanujan who recognized Hardy through that book. And it is all these people who are responsible for recognizing and telling him that you write to Hardy and send him your results. That is how Hardy was approached by Ramanujan with his first letter in the year 1913. And we are almost sure, I mean, most of the people who have studied Ramanujan's work at great length and spent years together, like Andrews, Ascii, Bruce Bund, and even me, Robert Rankin, a lot of people have studied Ramanujan. And Narayana Iyer was the person who was responsible for pushing him in the right direction at that time. Now, Ramanujan was 21, and he was already famous because he has he got a reply from Hardy. And the moment he got the reply from Hardy, he was being treated as a celebrity by all the people who knew him at that time, because it was not easy to get a reply like that from an established fellow of the Royal Society, a person with a MA, a professor at Trinity College in Cambridge, for a Cambridge University professor to write to Ramanujan a reply and tell him that he is interested. And quietly, he had requested Neville, who was coming to India, to look into those notebooks. And if he was convinced, to persuade him to go to England for doing his higher studies, to help him to do higher studies or spend more time doing research and learning things from him. So that was the fortunate circumstance of Hardy coming across, Ramanujan coming across Hardy's Orders of Infinity book in the Madras University Presidency College Library. That was one fortunate circumstance. The other was E.H. Neville visiting Madras after Ramanujan's first letter had reached the Hardy. So Janaki Ammal was a girl. Janaki, as she was called at that time, was only a 9-year-old girl in the year 1908, which means she was born in 1899. Ramanujan was born in 1887. So the age difference is 12 years. So Ramanujan was 21 and this girl was only 9 years old. And Komalathammal, who had gone to a marriage of some friend's marriage, saw this girl running around, and she somehow decided for her that this was the right girl for Ramanujan, and therefore negotiated and did everything even without consulting. Of course, took her horoscope, verified it with that of Ramanujan and all that apparently she did. But then she did not consult her husband. That is, Ramanujan's father was not even consulted. and the marriage was fixed. And the marriage took place in the year 1911, I think. It's missing here. The photographs are covering it, so I'm not able to see the exact year there. They also lived together for a few years after Ramanujan returned from England. So they essentially, at that time, since Janaki was only 9 years old, she had not come of age. The marriage had taken place for 21-year-old Ramanujan and 9-year-old Janaki. But they waited. So after the marriage, she went back to her parental home. And after she came of age, when she was about 13 or so, she came of age. And by that time, Ramanujan was established. And she came and joined him and lived with him for about 1 year before Ramanujan went to England in the year 1914. So after, and then he returned after 5 years in 1920. After 1920, he died after he came back in March 1919. He died within 1 year. On April the 26th, 1920, he passed away. So that is why this is Ramanujan's Remembrance Centenary year. Ramanujan died on 26th of April 1920. So after that, this lady lived for 74 long years. I would say that it was my fortune that she was alive. And I had an occasion when the director of my institute by name Professor Sudarshan asked me, it seems the Janaki Ammal is alive and the Hinduja Foundation wants to honor her. So that was my first contact with Janaki Ammal Ramanujan. So at least I can say that I was blessed to be in contact with this lady from 1987 till 1994. And many of the visitors who had come to Madras at that time, like Andrews, Ascii, Byrne, so many other people, Robert Rankin and others, I had taken them and introduced them to Janaki Ammal Ramanujan. The last person whom I did was Bela Bolabas, another fellow of the Royal Society from Cambridge University. When I was asked by Professor C.S. Seshadri, the FRS today, he's also now no more with us. He called me and said, Srinivas Rao, Bela Bolabas is coming to Madras only because he wants to see Janaki Ammal Ramanujan. So you know her very well. Why don't you take her? And he would be very happy. So I did that. So after 1920, she spent about 8 years in Bombay with her brother, who was R.S. Iyengar. And here is a story which she told me, which I am not going to reveal, which she said, don't reveal this. She went there with all her Stridhanam, but she came back almost without nothing except the fact that the brother helped her learn suturing, sewing, using the machine, the sewing machine. She also knew, she was also sent to school to learn to read and write. So she got the ability to read and write, and also the ability to stitch petticoats and blouses and dresses for children when she was in Bombay for about 8 years or so. But then I think the treatment which was being meted out to her by her own brother was very not satisfactory, and therefore she decided to come back all alone to Chennai. She came back to Chennai, struggled for a number of years, and I do not know. She had lots of problems, and then somebody died, leaving a small boy called W. Narayanan to be fostered by him. W. Narayanan was only 7 years old, and the mother of W. Narayanan, obviously she was a widow, or I don't know anything about the father of W. Narayanan, but the mother died when he was only 7 years old. So W. Narayanan was handed over to Janaki Ammal, saying that you bring him up. So Janaki Ammal saw to it that W. Narayanan went through his graduation also, and on many an occasion, apparently she did not, she was not shy. She would go and ask the chairman of the Madras Port Trust, I'm Janaki Ammal, and I want this for my foster son. So she got him a job she got him educated up to a bachelor's degree in Vivekananda College, and then he got into a job in State Bank of India. And there, again, thanks to Janaki Ammal, she was able to identify a lady by name Vaidehi and got them married. She was also a bank employee. So I knew both of these people very well. So whenever I wanted any visitor to see Janaki Ammal, I would call W. Narayanan, and W. Narayanan would even take half a day off and say, come after 2 p.m. I will allow the visitor to come and see Janaki Ammal Ramanujan. So I met her on many an occasion, so much so she even remembered my children's names, and she would ask, how is Arvind? How is Anand? She would ask. And in the last few years, she was very hard of hearing. So she will be asking in a very loud voice. And she died on the 13th of April, 1994, early in the morning. And I got a phone call from W. Narayanan saying that Janaki Ammal, my mother, is no more. And he took care of her like anything, both of them. In fact, both Janaki Ammal, both W. Narayanan and Vaidehi Narayanan resigned their jobs. They took voluntary resignment just to take care of this lady, because she was orthodox. She would not allow anybody to cook, except she would cook only for herself, and she would not allow anybody. And in fact, she was very fond of W. Narayanan. So W. Narayanan was absolutely necessary for her to be there all the time to take care of her and take care of the visitors who were coming. There were plenty of visitors, because by 1987, when she was recognized and the centenary of Ramanujan was celebrated, there were a lot of mathematicians who felt, is Mrs. Ramanujan alive? And since I belong to a research institute, many people who had come to my institute who had expressed their desire to see Janaki Ammal Ramanujan, I have helped them. Same is true with my wife, who was in the Ramanujan Institute. So she has also gone and seen them. So I had this fortune of being known to Janaki Ammal Ramanujan from 1987, when I organized a big function to honor her as the wife of Ramanujan, with a pension of 1,000 rupees a month until she died, by the Hinduja Foundation, plus an honorarium, a check of a one-time payment of 20,000 rupees, which is a lot of money in 1980s. And when she died, she acquired the house in which she was living, got that house into a very big place, rebuilt it, and she educated her W. Narayanan's 3 children. They're all educated by her. She provided all the financial support, and she gave money to several children. They would say that, if I were to say it in Tamil, that it is good for us, for this child to be blessed by you. So she would pay the fees for the examination of several of those children who consider her as what you call lucky charm for their future. Now, this is the first letter of Ramanujan. I would like the sponsors to tell me how much more time I can take. Hello? The organizers?
Sir? Yes, sir. 10 minutes left, sir.
10 minutes. 10 minutes. Good. So this is the first letter of Ramanujan, historic letter. This historic letter contained, I'll just show you some of the formulae which he wrote in that letter. You can see, if you have one factor like this, 1 plus x by b plus 1 whole square divided by 1 plus x by a whole square, and integral dx 0 to infinity, you and I would find it quite difficult to do. Ramanujan puts effortlessly ... which means that those factors are infinite in number, and he gives a beautiful closed formula, which is so nice that it's a beautiful result. And similarly, the next integral. Now, Hardy thought that as an expert in definite integrals, he could prove them very easily, but he did so with a great deal more trouble than he ever expected. But he never even thought of such a result existing, and Ramanujan pulled it out of his hat. On the whole, the integral formulae seemed least impressive. Now, look at the equation number 7. That is the example of modular equation. It is the simplest example which I can show you of a modular equation. You can see that the expressions on the left and the right look to be identical, except in one case you have alpha and the other case you have beta. They are identical expressions, except that alpha is replaced by beta. Now, that by itself would be a meaningless statement if alpha and beta are not related. So what is their relationship? The relationship is that if alpha beta, their product is pi squared, then this is equal. Now, this is a beautiful example of a modular equation, and Ramanujan was adept at modular equations, and that is considered to be the best work which he did during the last year of his life while he was dying. These are some series formulae, all are hypergeometric series. In fact, what you find above is one is a hypergeometric series on the left side. It's a product of 2 hypergeometric series on the right side. That is equation number 1. The second one is a summation theorem in hypergeometric series. The third one and the fourth one. All of them are hypergeometric summations. And Ramanujan discovered all these summation theorems, all that was known in Europe about summation theorems, he discovered by himself with the only hint of what is known as the Gauss summation theorem. So these are the integral formulae which I had shown you. Okay. What am I doing? And you can see the continued fractions. These are the ones which started baffling a person like Hardy. He said actually 8, which is a continued fraction on the right hand side for the error function 0 to a e power minus x squared dx, he says is equal to a continued fraction. Actually 8 is classical. It is a formula of Laplace, first proved properly by Jacobi. And 9, which is again a continued fraction. This is what a continued fraction is. In between 8 and 9, I've shown you what a continued fraction is. And 9 occurs in a paper published by Rogers in 1907. Hardy did not, Ramanujan did not know about it. It is Hardy who was able to show Ramanujan that that result was already published by. And here is something which baffled, and Hardy considered it sufficiently marvelous that Ramanujan should have even dreamt of problems such as these. You can see u is a continued fraction in x, v is a continued fraction in x, and it looks as though apparently all the powers of x are 1/5. In u, if it is x power 5, x power 10, here it is x power 1/5 instead of x power 5x, instead of x power 10, it is x squared. So you can somehow crudely guess that u and v may be perhaps related to a 5th power of u, 5th power of v may be related to u. That you can guess, but it will not be possible for you to prove the result exactly. The exact result is v to the power of 5 is u times a polynomial of degree 4 in u in the numerator and a polynomial of degree 4 in the denominator in the same variable u, which is a continued fraction. Now you should know how to multiply continued fractions, how to add continued fractions, how to divide continued fractions, and he knew all that. Obviously, he knew all that. And he again had a result like this, which including exponential function, e and pi, as you know, are transcendental functions. So you can see the continued fraction results which he has for them. And Hardy was completely bamboozled. He was taken by surprise, and that is what made him decide to bring him to England, take him to England. He went there, and his first communications were in the Journal of the Indian Mathematical Society, and his first paper was on some properties of Bernoulli numbers. It is a 69-page article. In fact, it was Hardy who saw to it that this paper of his on Bernoulli numbers, which he called as in the backwaters of mathematics, that's what he calls. But as far as his originality is concerned, he says it is completely original. So the paper on Bernoulli numbers, along with 5 or 6 other papers which Ramanujan had published by that time, were all strung together and put into the form of a file and submitted to the Cambridge University. And Cambridge University awarded him the bachelor's degree for that. And Ramanujan's methods were always so terse and novel, and his presentation so lacking in, forget about that. Then Neville was a lecturer who came, which I already mentioned to you. He was awarded the BA degree for the work which he did on highly composite numbers along with other publications. And that paper contained 269 equations, and it is 62 pages long. And that was sufficient for him to get the bachelor's degree in arts along with a few other publications of his. And Hardy again was finding that Ramanujan was finding it very difficult. On the one hand, he was a vegetarian. On the other hand, there was a war period, and therefore the few things like tamarind and appalam and things like this, I mean, you know, some of the eatables which he was trying to get from Chennai by ship, they were not coming, mainly because of the problem he was facing at that time. And all this rather made him feel very sad that he was not able to, and he was feeling depressed. So to boost his confidence, it was Hardy who suggested his name for the fellowship of the Royal Society. When his name was put up, apparently Eddington, a character whom people will know, who had interfered with Chandrasekhar and his progress in life, also tried to interfere in the case of Ramanujan and said that he can wait for 1 more year. But Hardy was definitely not going to let that happen. He put his foot down and said, no, it shall not wait for next year. It shall happen this year. So in the year 1918 itself, he was awarded the Fellowship of the Royal Society. And the citation read, Srinivas Ramanujan, Trinity College, Cambridge, research student in mathematics, distinguished as a pure mathematician, particularly for his love, for his investigation in elliptic functions and the theory of numbers. And Hardy also saw to it that he was elected to a Trinity College Fellowship, which was also worth the same amount of £250 a year for 6 years. He was on a 250 pounds a year for 5 years scholarship when he came to England. As soon as he arrived, here is a small snippet of information which I would like to tell you. As soon as he reached London, he got the first pay, he requested, when he was told that he will get 250 pounds a year, he told Hardy, please see to it that 60 pounds is transferred to my father. So as a dutiful son, he wanted 60 pounds to be given to his parents every year as out of his earnings. But Hardy was too good a man. When he realized that he was giving 60 pounds a year out of the 250 pounds which was being given to him, he supplemented that 250 pounds with another 60 pound scholarship. So that is the type of people with whom we are talking of today. Nobility at its best. Now, during Cambridge years, he published 21 research papers, 5 of them were with Hardy, and he got his BA degree, he got the fellowship with the Royal Society, and so on, which I mentioned to you. And now comes the famous episode of the taxi cab number, which most of you must be familiar with, because I think this has been bandied about and talked about by almost every Tom, Dick, and Harry, including politicians who know nothing about numbers and who are not interested in Ramanujan either. So the episode goes like this. It is Hardy's words. I remember going to see Ramanujan once when he was lying ill in Putney. I had ridden in a taxi cab number 1729 and remarked that the number seemed to me to be rather a dull one, and I hope that it was not an unfortunate omen. Ramanujan replied, no, it's a very interesting number. It is the smallest number expressible as a sum of 2 cubes in 2 different ways. I asked him naturally whether he could tell me the solution of the corresponding problem for the 4th powers. And he replied, after a moment's thought, that he knew no obvious example and supposed that the first such number would be a very large one. So 1 cube plus 12 cube equal to 1729 equal to 9 cube plus 10 cube is the smallest number, which can be expressed as the sum of 2 cubes in 2 different ways. The smallest number, which can be expressed as 2 4th powers in 2 different ways, is 635, 318, 657. A 9-digit number, which is 59 to the power of 4 plus 158 to the power of 4, or 133 to the power of 4, 134 to the power of 4. And apparently, Euler knew this solution to the 4th power problem. So this has been pointed out to us by people like Hardy and Littlewood. And Littlewood therefore makes the statement on one occasion that every integer is a personal friend of Ramanujan. This is the death certificate and what happened after Ramanujan's death. We are still talking about Ramanujan. His last notebook is being edited by by George Andrews, Richard Ascii, and Bruce Burnt. And so this story continues. So this is the stamp which was brought out on the occasion of his 75th birthday. This is the bust of Ramanujan which was made by Paul Granlund, which looks more like Chandrasekhar. And Chandrasekhar's sister herself agreed with me when I said that, but it's unfortunate. There are 10 copies of this, and out of these, except for 2, there are several where they are available is listed here. And the last notebook was discovered only in the year 1976, 56 years after Ramanujan died. Andrews was going through the estate of G.N. Watson. I mentioned to you, G.N. Watson is the person who did Bessel functions. So that G.N. Watson. So George Andrews was not interested in Ramanujan. He was going through the estate of Watson, and suddenly he discovered 100 blue sheets of paper with about 600 theorems scrawled all over here, right, left, etc. Because Ramanujan was apparently writing them down when he was dying. In the last year of his life in Chennai, in Madras, when he was dying, he was asking for paper and going on writing, and they were all put in a trunk, and they were all packed and sent to sent to Hardy, and they returned to Chennai and they went back again. So that's a big story, which I do not have the time to tell you. I have written biographical books on Ramanujan. And to now give you finally a few quotations about Ramanujan, Neville in his broadcast in 1941 said, Srinivas Ramanujan was a mathematician so great that his name transcends jealousies. The one superlatively great mathematician India has produced in the last 1,000 years. Paul Erdős, the Hungarian mathematician with whom I have had the pleasure of interacting because he came to Madras more than one occasion. He was a great admirer of children, and he supported Krishnaswamy Aladi like anything. to come up from his school days to whatever Krishna is now today. Krishna is known to me from his childhood. So Professor Erdős, the Hungarian mathematician, has passed on to us Hardy's personal ratings of mathematicians. Suppose we rate mathematicians on the basis of pure talent on a scale from 0 to 100. Hardy gave himself a very modest score of 25. To Littlewood, who he always considered and consulted as a better mathematician, he gave a score of 30. To Hilbert, who proposed the 23 problems at the turn of the 20th century, at the end of the 19th century, at the beginning of the 20th century, he gave the 23 problems. To him, Hardy gave a score of 80. But on that scale of 0 to 100, 1 to 100, he gave Ramanujan 100. Chandrasekhar, the astrophysicist and Nobel laureate, observed, as long as people do mathematics, the work of Ramanujan will continue to be appreciated. And this, I think, takes the plum or cake. I would consider as the icing in the cake. Richard Ascii says, try to imagine the quality of Ramanujan's mind, one which drove him to work unceasingly while deathly ill, and one great enough to grow deeper while his body became weaker. I stand in awe of his accomplishments. Understanding is beyond me. We would admire any mathematician whose life's work was half of what Ramanujan found in the last year of his life while he was doing. I told Richard Ascii, when I read this for the first time and I quoted it in my papers and in my book, I told him, sir, you have given a fraction half. I would say half is too much. Anybody who did a small fraction, a smaller fraction than that, could also be considered as great in mathematics. Now, this is the picture which was taken on the occasion of the centenary of Ramanujan when George Andrews gave the last notebook to her, first copy of the last notebook to her. And below is a picture. I'm not there in the picture. I'm in the right extreme, which you may not be seeing. Here, W. Narayanan, Vaidehi Narayanan, the Vice Chancellor of the Madras University, V.C. Kulandaswamy, the Central Minister at that time, C. Subramaniam, George Sudarshan, the Director of the Institute of Mathematical Sciences, were all present here in a function which I organized. For 1 hour, I put up a huge pandal and gathered about 400 people to come and sit there. And it was a 1 hour function in which Janaki Ammal Ramanujan was honored with a purse of 20,000 rupees check and a pension of 1,000 rupees per month, which I mentioned to you earlier. So with this, I think this is Janaki Ammal Ramanujan being honored on the occasion of the 75th birthday by a person called Selvaraj, who was the Port Trust chairman at that time. And Janaki Ammal, obviously, after such a function, with the garland in a silk saree and with a bright smile on her face. And this is the first book. For those of you who think that there are no books on Ramanujan except Kanigal's, I would like to say that the first book was written by S.R. Ranganathan, the library scientist, which was called Ramanujan, the Man and the Mathematician. That is the first biography which was written. Then the second biography was in Tamil by a person called Ragami. His name is T.V. Rangaswamy Iyengar, and he had a pseudonym Ragami. And Ragami wrote this book, which is entitled Ganidhamedai Ramanujan. Because it was written in Tamil, the Western world was totally unaware of this. So I took it upon myself by the responsibility of translating it into English and publishing it as Mathematical Genius Ramanujan. And this was during the year when I was a distinguished Ramanujan professor at Shastra University in Kumbakonam. During that period, I completed this translation of the book into English. And you can see what I have used in my cover design. You can see Ramanujan became the crowning glory of, that's a fountain there in Cambridge. It's my picture of Cambridge when I was there in Cambridge. And you can see the pictures of Hardy and Komalatammal in that. And finally, these are the busts of Ramanujan. You can see the bust of Ramanujan, which is there in the Ramanujan Institute for Advanced Study, the bust of Ramanujan, which is there in the Madras Port Trust, and the bust of Ramanujan made by Paul Granlund, 10 copies of which are in various places. Here I had already shown you my photograph with me, with W. Narayanan and Vaidehi Narayanan and K Srinivas Rao, my wife, on the occasion when we honored Janaki Ammal Ramanujan in our institute. And in 2010, when we had an ICM, International Congress of Mathematicians, for the first time in India at Hyderabad, both my wife and I, we participated. And at that time, there was a seminar on Ramanujan, and I am here seen with George Andrews, the discoverer of the last notebook of Ramanujan. And this is my tribute to Ramanujan in my own way. This is called a Pi Pavilion. It tells you the story of Pi, I, and E. That's a separate story. So when you have the time, ask me. I will come to your institution and teach you what I know. And here I am with Abdul Kalam. K Srinivasan is the person who was responsible for gathering a lot of information from various people. And he was a school teacher in Mutyalpet High School. I'm in contact with Mutyalpet High School and want to reproduce that book again so that other people will also be aware of what was done in India for Ramanujan after Ramanujan died. And the first copy of Wings of Fire is being signed by Kalam and being given to K Srinivasan. Here I am with Chidambaram and the director of my institute, Ramchandran. And Chidambaram is retired only last year as the chairman, the principal advisor to the government of India. And I'm happy to tell you that he has written a foreword to my latest book on Ramanujan, which is going to be published soon by Springer Verlag. And that will be an international edition. And here I am showing the Pi Pavilion to Dr. V.S. Ramamurthy, who was at that time the secretary. Now I will run through a few pages of Ramanujan just to give you an idea of what it is. I do not have time to tell you about the details, but these are a few pages of Ramanujan's notebooks. And this was an exhibition which I put up, and Kapil Sibal was the person who inaugurated this function. It was the 98th Indian Science Congress at Sairam University in Chennai. And at that inauguration, I was asked to do something on Ramanujan, and therefore I put up. And I am, of course, obviously explaining the simplest thing to Kapil Sibal about magic squares and what Ramanujan did on magic squares. These are the CD-ROMs which I have produced on the life and work of Ramanujan. And the website which I give here is the one which will contain all that you want to know about Ramanujan and his notebooks and his publications until the last notebook, part of it. So you can see the website www.imsc.res.in/Rao. That is my homepage. Below that, Ramanujan. And then you will get a slideshow, and you click on the slideshow, you will get all the information which you want to know about Ramanujan there. Okay, so thanks for your kind attention.
Thank you, sir, for taking us to a century back till date to explore the legends.
A lot of things which I have kept here, which I did not have time to show you. I had kept the notebooks of Ramanujan and various things which I wanted to show you. And okay, I had 32 posters like that for Ramanujan. Okay, I'm done. Thank you.
Thank you, sir, for taking us to a century back till date to explore the legends, accomplishments, and life history. It was very interesting, and hope our students will be benefited.
Thank you.
Let's have the questioning session, sir.
Good.
Students, anybody is interested in asking any doubts or questions? You may raise your hand now.
Mr. Sridhar, you are a mathematics professor? No?
Yeah, sir. I'm Dr. Shanti. Actually, I'm logged into a different name.
Sridhar below
Yeah, that is someone else ID. It's like technical error.
Okay. Glitch. So you are a mathematician?
Yes, sir.
Where do you teach?
I teach in Sairam Engineering College.
Oh, good.
I'm a professor here, assistant professor here. I was there in the meetings, sir, last week.
Oh, good. I saw so many of you. I don't know whether you're there in the photograph. And that's why I said, let me take a photograph of some of you because I can then remember you.
No.
And
unfortunately, I was not there in the photograph.
And I did not get any answer for that in that photograph which was taken. Okay. Any questions from the audience? Shoot.
Yes, students, you can ask your questions.
Teachers also.
Okay, I don't think they have any questions, sir. We have few announcements. Actually, we had some competitions held on account of this celebration. And now I'll present the winners of the poster presentation and quiz competition. The poster presentation winners are, the first prize is backed by Chandra Geetani of first year IT B section. And the second prize is backed by Madhumita S of second year ICE. And the third prize is PN Darshini, third year ECE D section of Sairam Engineering College. And next, quiz competition. The first prize is backed by Akshaya Kamalavasan, CCE of Sairam Institute of Technology. The second prize is backed by Aravinda Raj, second year SEC Sairam Engineering College, CAC department. And the third prize is backed by Sridharan of third year Sri Sairam Engineering College, Mechanical department. Students, the prizes and certificates will be given later. Okay, now we'll move on to the concluding session of the program. And let me invite Dr. Shubhatra ma'am to deliver the vote of thanks.
Good evening, one and all present here. First of all, I would like to express my sincere thanks to our CEO, Mr. Sai Prakash Liyamuthu, for encouraging us to conduct club activities. I thank our principal, Dr. A. Rajendra Prasad, for motivating and guiding us to organize various department activities. I thank our speaker, Dr. K Srinivas Rao, for accepting our invitation immediately without any hesitation. Thank you, sir. So you have explained Srinivasa Ramanujan's early life in an excellent way, sir. Thank you. Today we are very fortunate to listen to your lecture, sir.
Most welcome.
I hope the participants
are you in the night on the Doordarshan between 7:30 and 8. Please announce it to your friends if they are interested. It will be a different type because it will be a question-answer session.
Okay, sir. Okay, we'll announce it, sir. I hope the participants will get some information about Ramanujan's life. I thank our HOD, Dr. S. Ramakrishnan, for his commitment and dedication towards Max Club activities. Last but not least, I thank my fellow colleagues and my dear students for making this program a grand success. Thank you. See, today night between 7:30 to 8, Dr. Srinivas Rao sir is presenting a question and answer session in Doordarshan. Those who are willing to participate, willing to watch that event can watch in Doordarshan. 7:30 to 8 only, sir. Between 7:30 to 8 in Doordarshan.
Okay. Thank you. Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Most welcome.
Okay.
Thank you, sir. Thank you, sir. Professor Srinivasa Rao, sir. Ramakrishnan.
Ramakrishnan,
sir. Thank you, sir. Thank you.
Okay. Nera paatla, sir. Other attention.
I saw you on the screen at the beginning. Thank you very much.
Okay, sir. Thank you.
Good evening.